Good evening, Honors Algebra. Mr. Lawrence here with your flip lesson for, I'm doing this early. I'm so messed up. There's so much going on. Oh, please, Christmas, don't be late. All right, December 14th. It should be Wednesday night's lesson. All right, and now, Tuesday night's lesson was to watch the December 9th video again and revisit how to graph inequalities, right? And remember, those either have a solid line or a broken line, and then they have shading involved. And then in class yesterday, today, after you finish the RECA assessment, you worked on graphing some inequalities. Okay, well now we're going to graph what's called a system of inequalities. Today we are graphing systems of inequalities. And all that means is we're going to have two graphs, two lines on the same graph. Okay, and it's actually kind of cool. It visually looks really neat. All right, so let's say we have a simple inequality like this. Pardon me, Mr. Recorder, you're in my way. Y is greater than or equal to negative 1/2 x plus 4. All right, well, I'm going to go ahead and graph that. My y-intercept is 4. 1, 2, 3, 4. I know this because I'm in slope y-intercept form. And then my slope is down 1, right 2. Down 1, right 2. Down 1, right 2. Hold on 1 second, folks. Sorry about that. I was having a little problem with my orientation, and so I went down 1, right 2. Then I need to go down 1 over 2 more. Down 1 over 2 more. That looks a lot better. All right. So let me get this line drawn. Now it'll be a solid line, right? And I'm going to go ahead and make it blue. Down 1, right 2. And I'll change the thickness and all that in just a moment. Okay. Properties. Give some arrow points, and let's make it nice and thin. Okay, now remember, because it is an inequality, I need to determine where to shade. So I'll plug in a test point, say 0, 0. I'll put 0 is greater than or equal to 0 plus 4. I plug 0 in for x, negative 1/2 times 0 is 0. So I get 0 is greater than or equal to 4. Is that true? Or there's my test point. Is 0 greater than 4? Absolutely not. So I will shade, oops, wrong button, where my inequality, I'll shade away from the point 0, 0, because that was my test point. If I'd gotten a true statement, I would shade where the test point was. But since I got a false statement, I shade the other side. Okay, so there we go. Now, of course, that shading goes on forever above that line. Okay. All right, now, let's say we have this inequality, because remember, we're doing a system. And let me see if it'll let me do this. All right, y is less than, let's go with 3x plus 8. Let's make that a 6. That ought to work. We'll make that a 6. All right, so I'm in slope y-intercept form. I go up 1, 2, 3, 4, 5, 6. There is my y-intercept. My slope is 3 over 1, so I rise 3, run 1. Running out of room, so I'll go down 3, 1, 2, 3, run 1. I know that I need a broken line here. A broken line. So I'll take my broken line like this. And I'm going to change its thickness and color here in a moment. Properties. And I'll make it a nice dark yellow. All right, now I have to decide where to shade. Well, again, I'm going to plug in 0, 0 as my test point. I like testing with 0, 0. There's my test point right there. 0 is less than 0 plus 6, which simplifies to 0 is less than 6. That is a true statement, so I will need to shade below that line. So I will start shading everything that has the test point. And look at this. Do you see the blue and yellow making green? That region is my solution. What does that mean? Well, that means that every single point in that region satisfies both inequalities, would make both inequalities to give true statements. If I picked a point, say right here, okay, what are the coordinates of that point? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. That's the point 5, 6. If I plug 5 in for x and 6 in for y into both inequalities, they will both yield a true statement. So the solution is this green region here. It includes an infinite number of points. Okay, it's actually kind of cool. I love the visual of how the blue turns to green. We're going to look at another example. Let me get my graph paper out here. Okay, here are my two inequalities. My second one, the yellow one, is written in point slope form. So first thing I'm going to do is find the point. Oops, I'm not in writing mode, pardon me. I'm going to find the point. I know it passes through the point -3, +1. Remember point slope form? Right, this stuff doesn't go away, folks. All right, so I'll go to -3, 1, 2, 3, and then +1. And then I see my slope is 1/4. So I will rise 1, run 1, 2, 3, 4. Rise 1, 1, 2, 3, 4. 1, 1, 2, 3, 4. And I will then go ahead and draw my line. It is a broken line. No, it is not, Mr. Lawrence. It is not a broken line. It needs to be a solid line, right? So first thing I'll change that. Mr. McLean can tell you why it's a solid line, I'll bet. Okay. There we go. Now I have to decide where the shading is going to occur. Well, I will plug 0, 0 in and see if I get a true statement. So I'm going to erase my point and slope because they're in my way. I get 0 minus 1 is less than or equal to 1/4 times the quantity of 0 plus 3. Well, that means that -1 is less than or equal to 3/4, and I believe that is a true statement. So I tested with 0, 0. By the way, when is the only time I can't test with 0, 0? Do you remember? If you said when the line goes through the origin, that is true. All right, so I'm going to shade everything below the region, everything below that line. And the solution includes this entire region, right? Okay, easy so far. Now, you don't have to shade it absolutely perfect. I'm trying to do a good job on here, but, you know, it doesn't have to be 100% perfect. Properties, object animation, fill effects. I don't think that helped. Okay. Anyway, let's go ahead and do the other one. This one's in standard form. So I know that the y-intercept can be found by doing c divided by b. In this case, that would be 6 over -3. And that would simplify to -2. So I graph the point 0, -2. 1, 2. Now I have a choice. I can find the x-intercept or find the slope. I think I'm going to go ahead and find the slope. I know that's -a over b. And in this case, that would be -2 over -3, which simplifies to 2 over 3. So I will rise 2, run 1, 2, 3. Rise 2, run 1, 2, 3. Rise 2, run 1, 2, 3. Okay, I'll go down 2, back 1, 2, 3. All right, now I'm probably going to have to extend my graph a little bit further here because I'm noticing that the lines aren't intersecting right away, so I'm going to shade over here like this a little bit more, and we'll see what happens. Okay, let me get a nice blue line here, and it's got to go back to 1, 2, 3. Okay, it's going to look something like that. And let's see here. Properties, I want some arrowheads. I want some arrowheads. And that's good. Okay, this yellow line I'm going to need to make longer to find out where they cross. Okay, now I will do my test point for the blue equation. I'll plug in 0, 0, which makes my work real simple. So I am going to test 0, 0. I put 0 minus 0 is greater than 6. Look, if I put 0 in for x, I get 2 times 0 is 0. Put 0 in for y, I get 3 times 0 is 0. So the left-hand side is just simply 0 minus 0, or even more simply, 0. It's greater than 6. That is a false statement. I will not shade. I will not shade where the test point is. I will shade the other side. Oh, I have a small error, don't I? This line here needs to be a broken line, does it not? Yes, it needs to be a broken line. There we go. Okay, so now I'm ready to shade. I'll get my blue highlighter, and I'll begin to shade the other side of the line from the test point. Do I have a small mistake on my 1, 2, 1, 2, 3, 1, 2, 1, 2, 3? Yes, I do. I have some mistakes on my blue points. All right, let me fix those real quick. Let me see here. My y-intercept is correct, so I go up to right 1, 2, 3. Ah, there it is. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Oh, that's even better. That way we can see where the two lines intersect. There we go. Let me get my highlighter back in there. Sorry about this. Momentarily delay. Whoa, I'm supposed to be highlighting. There we go. Okay, now it doesn't change where I shade. So I get my blue highlighter, I shade the other side of the line from the test point, and there we go. Look at all that green, and up there it's blue. Why? Because there's no yellow up there. The solution set is everything included in the green region, and of course this green region extends forever. It just keeps going. Okay, it does have a boundary over here. It's got this boundary. Oops. So don't use the black marker, Mr. Lawrence. It's got this boundary here, right? But every point from here down this way makes both inequalities true. Okay? All right, that is it. So when you come into class on Thursday, you'll be working on solving systems of inequalities. This is Mr. Lawrence signing out.